Hello everyone, welcome to Almighty Tricks. In this video, we'll be understanding about strategy design pattern. We'll be seeing a real-time example and try to understand how can we use strategy design pattern in that example. Then we'll see how can we use factory design pattern with strategy design pattern. Let's get started with a real-time example. Okay, so I have opened Google Chrome and I have opened Google Maps site. And let me go to the direction. So if you see, there are two fields. One is the starting point, another one is the destination. And you can see these four options like car, bikes, then bus, walk, flight, then cycle. So if I put something like starting point and destination point, then it will show the time to travel to that destination, from source to destination. So that time it will show. Okay, so basically internally it will calculate the best route from starting point to destination, and it will give the optimal time. Okay, so let me put one starting point, Kalyan Nagar, and destination, let's say Electronic City, Bengaluru. So if I do that, if you see here, I am getting if I travel via car, then it will take 55 minutes. By bike it will take 56 minutes. By walk it will take 5 hours. Okay, so let me click on this walk. So if you observe this one, so it is changing the path. Okay, and similarly if I click on the bike, it is changing the path. Also it can go to through this path also we can go. Okay, but optimal path is this one. Okay, similarly if I click on bus, so it will show some different path. Okay, so let's have one class and there we'll try to implement best path we can find using different mode. Okay, I have created one Google Map client class. Okay, and in that Google Map client class I have used this scanner to take the input as a string mode. So mode is basically whether we want to go via car or walk or by bus. Based on the input we will execute the appropriate logic. Okay, so I have created one if condition. So this if condition is checking whether this mode is car or not. If it is car, then it will we will have one logic to find the best path. Okay, and let's say there are hundreds lines of code to implement that logic. Okay, similarly for mode equals to walk, if we are choosing walk, so for that also we can write the logic for the walk, and we have, let's say, 200 lines of code for this logic. Okay, let's say in the future we want to implement mode is bus or maybe bike, so in that case we need to put some other if condition. Okay, so basically if you see here, this single class has lots of responsibilities, right? Lots of responsibilities, like the logic will for the car it will have, the logic for walk it will have, and similarly let's say in future we want to implement some other mode, so for those mode also we need to have the logic in this class only. So basically this approach is breaking SRP principle, right? So single class has multiple responsibilities, so it is breaking SRP principle. Also it is breaking OCP principle as well. How it is breaking OCP principle? Because if we put, or if we want to support some other mode like bike or maybe bus, so in that case we need to change the code in the existing code base, right? So in this case it is breaking OCP. So if you don't know about all these things, this principle, maybe you can check out my solid design pattern principle. So now let's understand how we can solve one by one. Let's say let us solve first this SRP principle, how we can solve this SRP. So to solve the SRP, what I can do, I can take this logic to a class. Okay, let's say I can take to, let's say, car mode. So I'll create one car mode class. So in that car mode class I can have this logic. Similarly this logic I can have another class, that is walk mode class. Okay, so for that I can do like this. So I can have this Google Map client class. Let's say this is client, and I can have two more classes, let's say car mode and walk mode. Okay, so in future let's say we want to use bike mode as well, so in that case we just need to create the bike mode. So now in the client class we need to create object of car mode, we need to create object of walk mode, and we have some method like, let's say, find path. Okay, find path. So in this path method we can have the logic this logic we can have, all these logics we can have in this method, find path and find path method. Okay, so we need to create the object of this car mode, then we can call this find path, and then we can have object of walk mode, then we can find the path. Okay, let's do that. So in the Google Map client class, I can have this scanner to take the input, and based on the input I'll check whether it is car mode or whether it is walk mode. Okay, so if it is car mode, then I'll create the object, then I'll call this find method. Similarly, if it is a walk mode, then I'll call the find method, okay, which is present in the walk mode class and car mode class. Okay, so here we are able to solve SRP. We are able to solve SRP here because we are not giving all the responsibility to this class. Okay, and we are just extracting all the logic to the appropriate class. Okay, so here it is solving SRP, but OCP principle is breaking here. Okay, and also it is breaking dependency inversion. Why dependency inversion? If you see, this is a class, okay, and this is also car mode is also a class, and walk mode is also a class. Okay, so Google Map client class is directly interacting with the car mode class. So dependency inversion is saying the two concrete class cannot talk to each other directly. They should talk via an abstraction. Okay, this abstraction can be an interface or abstract class. Okay, so here basically it is breaking dependency inversion as well as it is breaking OCP principle. Okay, so how can we solve this dependency inversion? Okay, so to solve the dependency inversion, if you observe one thing, this find method is the name is same, right? What we can do, it may be different name we can have, but what we can do, we can have one interface, and this interface will have find path method, and we can have this class car mode class which will implement to this interface. Similarly, we can have walk mode class. Similarly, it will implement this interface. So we need to override this find path method, and here we can write the logic for car mode and walk mode. Now, so this structure is basically called strategy design pattern. Okay, so what strategy design pattern is saying? So strategy design pattern is saying if there is a task which can be performed in different ways, in that case, instead of coding all the solution in a class like how we did in the first solution, so all the solution we did in one class, so instead of doing that, better create separate class for each solution and bind them with an abstraction. Okay, so what we did here, so for each solution, so here in the first solution we have different solution, right? So we have car mode solution, we have walk mode solution. For each solution, what we did, we created separate class. Okay, and we bind all this class to a abstraction, to a interface, or can be a abstract class. Okay, so this is what a strategy design pattern is saying. So where we can use strategy design pattern, if there is a problem and that problem can be solved in different ways, so in that case we can use strategy design pattern. So strategy design pattern can have this interface, and this interface can be implemented by these classes. Okay, let's code this one. Let me create one package called strategy. I'll have one interface. Let me create first client, Google Map client. Let me have the public static void main, scanners, sc new scanners system dot in. So it will take the user input, and let's say string mode is equal to sc dot next. Okay, let me create one interface. Let's say I Google Map path strategy. Okay, so here I can have one method void find path which will take nothing. Okay, now let me create class that is car mode. Similarly, let me create another class, that is walk mode. So walk mode will implement this Google map path strategy. I need to override that find method. Let me put some print statement, path for walk. Okay. Similarly, let me implement that interface in car mode as well. Here I need to override print statement, let's say path for car. Okay, now let me go to the client. Here what I'll do, if mode is equals to car, then I need to create new car object, car mode object. Okay. Similarly, else if mode is equals to walk, then I need to create walk object. Okay. Else what I'll do, I'll throw exception, throw new illegal exception, let's say invalid input. Okay, let me run this, then we'll see what are the issue still present in this class. Okay, I need to put, okay, let me have I base. Okay, it should be null initially. Then what I'll do, if it is creating object, car object, then I'll assign to this one also I'll assign to this. Then finally I need to call that find path method. Okay, let me run this again. Let's say put the car, so it is showing path for car. Let me run it again. I'll put something else, let's say bike. For bike it is not there, so it will give the invalid input, but still there is some issue. So one thing is dependency inversion is solved here, because it is not directly talking to this car mode. So it is this client is talking to car mode via this interface. Okay, so dependency inversion is resolved. But if you see this is client, we are exposing the creation logic to the client, this object creation logic to the client. So it is not a good idea to put object creation logic in the client class. Okay, so for that what we can do, we can have factory design pattern. Okay, so let me create one factory. We can use factory design pattern with strategy design pattern. So that's what I am doing now. Okay, so I can have one method public, which is Google map path strategy type, then create object. Okay, which will take the input, let's say string mode. Okay, then what I'll do, I'll directly cut this thing and I'll paste here. If you don't know about the factory design pattern, I have already explained that one. You can check out that in my playlist. And I'll return directly this one, this object I'll return. I no need to assign to something. Return this. Okay, now I'll call this factory method. So I'll create new factory, then I'll call create object, then I'll pass this mode. Okay, let me run now. Let me pass the mode as car. Okay, so path for car is working fine. Let me run it again. So let's say bike, so it will throw exception. Okay, which is working fine. Now it is so the creation logic of the object is not exposing to the client, so it is resolved now using factory design pattern. Also it is resolving OCP principle. Okay, so here we no need to, so this is our business logic, right? So this is our business logic. In the business logic we can have this if condition and we can use let's say in future we need to support for bike mode, so in that case we can change the code. Okay, so here basically it is not breaking the OCP. So if you don't know about the OCP, you can check out my playlist. So this is about strategy design pattern, and I have used factory design pattern with strategy design pattern to solve this type of problem. So if you watch my last videos, I have explained about adapter design pattern. So in that adapter design pattern, let me open the diagram for adapter design pattern. So in the adapter design pattern, we have this interface. Then that interface can be implemented by multiple classes, and we can have one factory class where we are creating the object. Then we can have the client class. Okay. Now let me open the diagram for the strategy design pattern. So if you compare the strategy design pattern with the adapter design pattern, the structures are very much similar. Okay, so here also it is, these classes are implementing this interface. Then we can have one client class, then we can have one factory class where we can create the object. Okay, so these two design patterns, the structures are same, but they are solving different problems. Okay, so in the adapter design pattern we are solving, where we can use the adapter design pattern, we can use the adapter design pattern if we have requirement to interact with the third party APIs or SDK. In that case we can use the third party, we can use the adapter design pattern. But in strategy design pattern, when we can use if there is a requirement, that requirement can be solved in different ways. So in that case we can use the strategy design pattern. So both the design patterns are solving different problems, so we should not confuse with the structure. Okay, so that's all about the strategy design pattern. Hope you understood all these concepts. Thank you for watching this video.